Good morning to all of you. Myself, Yogan Narayan Prajapati. I am as a assistant professor from Ajay Kumar Garg Engineering College, Ghaziabad. Today, my lecture, multiplication algorithm in sign magnitude representation. This topic is related to the computer organization and architecture. This is very complicated topic, so I am going to teach with algorithm, flowchart, and with numeric example. Now, when we are going to start any complex topic, then we take the first very simple example. What is the procedure for the any multiplication algorithm for the two number? We take very simple example. Now 1 0 1 1 and 1 0 0 1 1. Now this is the multiplicand and this is the multiplier. Everybody known that 1 multiplied by 1, that is 1. 1 multiplied by 0, that is 0. 0 multiplied by 1, again 0, and 0 multiplied by 0, this is the 0. So this rule we apply in this multiplication algorithm. By the commutative law, we can assume any value in multiplicand and any value in multiplier. We assume that this is the B and this is the Q. Then we multiply B multiply Q. Now 1 multiply 1, according to this rule, answer is 1. Similarly, 1 multiply by 1, answer is 1, and 1 multiply by 1, 1, and so on. When we go for the next digit 1, then here we shift 1 bit to the right side. When we conclude these things, it means when we going to perform the multiplication operation, we perform the two operation. First one is the multiplication operation. First one is the multiplication operation, and second one is shift 1 bit to the right side. It means when we perform the multiplication operation, we perform only two operation, multiplication operation and shifting operation. Similarly, 1 multiplied by 1, using these rule, we conclude this answer. Again 0, shift 1 bit to the right side, to the left side, and perform the multiplication operation using these rule. 0 multiplied by any bit, answer is your 0. Again for this bit, answer is here. And in last, for the 1 bit, this bit, answer is computed here. It means using two operation, we conclude this answer. What is the final answer? Final answer, add all these, then we conclude the final answer. It means one more operation are required for the multiplication operation. That is known as the addition. In last, we add 1 1 0 and 0 1 1 0 0 0. For the binary operation, for the addition, 1 plus 1, that is 0, that is the sum, and carries 1. Using these rule, we add these bit and find the answer here. 0 plus 1, that is 1, and carries 0. 0 plus 0, that is 0 and 0, and 1 plus 0, that is 1 and 0. So using these rule, we find this solution, final solution for the multiplication B and Q. Now this is the normal multiplication algorithm we are using for the any two binary number. This is the hardware required for the multiplication of the two number. Means the first value are stored in register B and the second value are stored in the register A. The sign of B value are stored in the B sign, and similarly the value of A, and here we are store the sign. And A multiplied by B with the help of the complement and adder, we multiply A and multiply by B. and when we add these two numbers, carry bit are stored in the E flag register. This is the hardware. Here is a sequence counter. Sequence counter told that how the total number of size of the bit for example, here 1, 2, 3, 4, 5. It means we need the 5 time multiplication. The value of sequence counter is 5. Okay. And last one, what is the Qn? Qn is the first bit of the Q register. So this is the overall architecture, hardware implementation for the multiplication of operation. We conclude that two registers are required, register A, register B. With the help of the complement adder, we multiply register A and register B, and when we add, we require another flag register, that is register E, and the sign of both data are stored, the sign B and sign E. And how many time of the multiplication are required? With the help of the stack counter, we count the how many number of the multiplication are required. Now here is the value, register A, two registers are required for B and Q are used for the multiplicand and multiplier. Two register B and Q, with the help of we multiply the two value. In starting, register A used to store the product of during the multiplication, and the value of A in starting are 0, 0, 0. And in B we store the multiplicand, and in Q we store the multiplier, where we are going to multiplication. With the help of sequence counter, it is the total number of bit 1, 2, 3, 4, 5, that is the SC, and SC for this problem is N, and for this the total number of bit 5, then the value of SC is 5. It means total 5. Here is a 1, 2, 3, 4, 5, 6. It means 1, 2, 3, 4, 5, 6. 6 time multiplication is required. That value is known as the SC. And flip-flop, in which we store the sign bit of the two value, that is register A and register B made for the flip-flop, and use for the carry bit during the multiplication operation. We are using the flag register. Now this is the flow chart for the better understanding. Here from the start, multiplicand and multiplier. Multiplicand, we assume that this is the multiplicand, and Q is, suppose this is the multiplier. B and Q are stored in multiplicand, and multiplier are stored in B and Q. Okay. Now in starting, A is tend to 0. In starting, A tends to 0, but the length of bit of the A is depend upon the length of bit of multiplicand or the length of bit of the multiplier. It means here A should be 6 times 0. Okay. Now in starting, that is the E. What is the is a flag register in which we can store the carry bit when we perform the addition operation after the multiplication. It means in starting, carry is also 0, no problem. And what is the sequence counter? That is N, or that N value is depend upon the multiplicand and multiplier, totally based on this value. It means for this example, Qn is, what is the Qn? 6. It means 6 time multiplication for the require. Okay. Now here Qn, what is the Qn? Qn, now Q is 1, 1, 0, 0, 1. Now this one is a Q. The first bit of Q is known as the Qn, or now this is the 1. Okay. Qn is the first bit of the Q, and check Qn. There is a two condition when we are checking any values. It is either 0 or it is either 1. If it is 1, then we simply add this B, this A. If Qn is 1, then what is the operation? We add A plus B. Now A in starting, you know that is very well, A is 0 0 0 and B is all again given 1 0 0 1 0 1. Now we are adding A plus B. That is the first operation. Second operation, after the addition, we shift. Here only mention this shift, but we are using the logical shift. We are using the logical shift operation. We shifting 3 register E, register A, register Q. Now register AE, AQ. Shifting one but to the right side. Logical shift right side EAQ. That is the second operation. And after shifting, SC is tends to SC minus 1. Okay. Now this one is the main algorithm for the multiplication operation. After decrement operation of the SC, we check the SC. If SC is 0, then end the processing. If SC is 0, end the processing. If SC is not 0, then again we move to the step number this and again check Q1. Again check Q1. If it is Q1 is 1, then add A plus B, shift and SC is equal to SC minus 1. That is the condition 1. Now say for the second condition, if SC Q1 is equal to 0, then what type of the operation perform? Only shift and SC is equal to SC minus 1. And in both case we check SC. If it is 0, end the processing. If it is not 0, move to the again step 2 and again check Q1 if it is 0 or 1. This process continue until SC is equal to 0. Same here is written initially multiplication R store in B register and multiply R is in Q register. Sign bit similarly we are stored in the BS and the sign of Q always are stored in the QS. Okay. Or with the help of the XOR gate, we check the sign of with the help of XOR gate, we check the sign of Q and the sign of the B. If it is 0, it means sign is different. If it is 1, then sign is the same. Okay. Now check Qn. If it is 0, then only shift operation perform. Shift EAQ and for the similar fashion. If it is 1, then add A plus B. If it is 1, then EA, A plus B and similarly shift EAQ to the right side and SC is equal to SC minus 1 and check SC. If it is SC is equal to 0, then end the process. If SC is equal to not 0, then move to the second step number 2 and again check Qn if it is similar process. We take the very simple example to conclude this algorithm and hardware implementation. Now multiplicand is 1 0 0 and multiplier is 1 0 0 1 1. Now I think this value is 1, 2, 4, 8 and 16. Now 16 for 20, 22 and 23. It means this value is 23. Now what is this value? 1, 2, 4, 8 and 16. And this value is 16 to 18 and 19. This value is 19. And we are going to multiply 23 multiply by 19. And here is a result. Here is a result or compute. When SC is equal to 0. When SC is equal to 0, then end the process and result are stored in A and Q. Okay. Now here we draw again the flow chart. Here Qn, if it is 1, then EA plus B and shift EAQ and SC is equal to SC minus 1. This is the main algorithm. If Q1 is equal to 1, EA, A plus B and shift EAQ and SC is equal to SC minus 1. Now in starting, A is 0 and Q is here given, that is the value of the Q, that is 19, and SC is equal to, now this is the 5, 101, that is a 5. Now check SC, sorry, check Qn. What is the Qn? The first bit of Q. Now this one is known as the Qn. Or Qn is 1. If Qn is 1, then what type of the operation is performed? Simply add A plus B and shift A, EAQ, and SC is equal to SC minus 1. If Q1 is equal to 1, then 3 type of the operation is performed. Now Q1 is 1, then add, this is A and now this is the B. Add A plus B, this is the value of B. 0 plus 1, 1, 0 plus 1, 1, 0 plus 1, 1, 0, 0, 0, and 0 plus 1, 1. Now this is A plus B. I already told you that in starting E is equal to 0 and A is equal to 0. Now shift Q1 is equal to 1, add A plus B and shift EAQ. These operation is performed. Now shift this bit, it means this 0 move to the here and this one move to the here, this one 0 move to the here. Similarly, this process is continue when all bits shift to the right side. Now we here taking 0, 1, 0, 0, 0, 0. Now this and this bit is shift from this bit and last bit is discard. Last bit is discard. Now when this bit is shifted, this is E, this is A, this is Q. We here for the better understanding we here write this is E, this is 1, 0, 1, 1, 1. Now this is A, now this is Q, 1, 1, sorry 1, 0, 1, 0, 0, 1, 1. Now this 0 shifting from here 0, this is shifting from here 1, 0, 1, 1, or this 1 shifting from here 1, 1, 0, 0, 1, or this last bit 1 is discard. This bit is discard. Now this is the process for the shifting, or this is your final. After shifting here this value 0, 1, 0, 1, 1, 1, 1, 0, 0, 1 and SC is equal to SC minus 1. After shifting, shift SC is equal to SC minus 1, SC is equal to 5, here SC is equal to 4, it means SC is equal to SC minus 1. This one step is complete, or one process is complete from here to here. Again we check SC. If SC is equal to 0, end the process. If SC is equal to not 0, then again check Qn. 4 is not 0, it means again we check Qn, or what is the value of Qn? Again Qn is 1. Then we process the similar operation. It means A plus B. Now this is A, or now this is the B. Add A plus B and shift one bit to the right side, and SC is equal to SC minus 1. These 3 processes we are apply when Qn is equal to 1. Now 1, 1, this is A, this is A, now this is the B, 1, 1, 0, 1, 1, 0, and carry bit 1. Now this is the A plus B and shift one bit to the right side. Now this is the last bit is carry. Now this 1 it's shifting. Again we are checking here 1, 0, 0, 0, 0, now 1 and 0, and here is a 0, 1, 1, 0, 0. Now when shift one bit to the right side, this one comes here 1, 0, 0 and 1. This 0 shift from here 0, 0, 1, 1 and 0, or this 0 is discard. It means this answer are coming after the shifting. You can check it here, this value and this value are same. You can check it. And SC is equal to SC minus 1. It means 4 minus 1, 3, this value is 3 and one step is complete. Again check SC, 3 is not 0, then again we move, check QN, and this time QN is 0. QN is 0, only shift right EAQ and SC is equal to SC minus 1. Now shifting this 0 here and this one here and 3 times 0 is here and 1 is shifting from here and 1 bit shift to the right side and this 0 is discard and this 0 is shift from the here and SC is equal to SC minus 1. It means 3 minus 1 is 2. Okay. Now again check SC, 2 is not equal to 0. It means again we move to the next state and check the QN. In this time again QN is 0. QN is 0. Shift EAQ and SC is equal to SC minus 1. It means this 0 is shift from here. It means 2 0. 1 is shift from here 1 and this is a 2 0 and this last 0 is shifting from here. Last 0 is shifting from here and this 1 is shifting from here and 0 0 and this 0 is discard. 1 1 is your last bit and SC is equal to SC minus 1. 2 minus 1, that is 1. Again check SC, SC is not 0, so that we again move to the checking state and check QN. Now here QN is 1, QN is 1. For the one case we add A plus B and shifting operation. Now this is your A, now this is your B. This is your A and now this is your B and add 0 plus 1, 1, 0 plus 1, 1, 1 plus 1, 0, carry forward here 1 and 0 plus 1, 1. Now this bit for the A plus B and after the addition we shift 1 bit to the right side. Now this 0 is shifting from here and here and this 2 1 is shifting from here and similarly this last one is shifting from here. Now 1 0 0 and this last bit are shifting and SC is equal to SC minus 1. Any 1 minus 1 0. If SC is equal to 0, what is the procedure? End the process and result are stored in A and Q. Now the final product in A and Q, or now this is your final answer. Conclude, what is the value? I think answer is computed, and for the better understanding in the next class we take another example for the more explanation for this algorithm. Thank you.